Each portfolio on the Markowitz EV frontier is the solution to an optimization problem, and we are going to show that optimization problem in this video, and we're going to demonstrate it in Excel. Again, we are going to demonstrate it with our four assets here: stocks, T-bills, T-notes, and land. You see the expected return, standard deviation, and the correlation coefficients between these assets here. And again, the asset or the optimization problem that we're going to solve is we are going to minimize the variance. So we're going to minimize the variance. You see in equation 1 the equation for the variance listed there. That is subject to the following constraints. Number 2, or the second equation, first constraint is that the expected return, right-hand side of the equation, is greater than a constant that we set to find our portfolio here. We're expected returns, we're holding it fixed. We're finding the portfolio that then minimizes the standard deviation. Number 3 is that all the weights have to sum to 1. And number 4, each weight in the portfolio can't be less than 0. It has to be 0 or greater. So now let's go to Excel and see the implementation of this problem. All right, we are in Excel. Here's asset 1, return, 2 return, 3 return, 4 return. This is stocks, T-bill, T-note, and land. Here's our portfolio right now is 100% stock. Our standard deviation or variance are here. See the other video on how we calculated those. Here's our minimization problem we're going to set. I'm going to put that right here. And now the way we're going to do that in Excel is to use Solver. Solver's an optimization problem. You will find this on the Data tab. Hit Solver. And here the solver is, and I'm going to set this up here, the optimization problem that you see listed here. You can do this for any different types of problems. Again, we're doing it for the portfolio problem. We are going to minimize the variance, F12. We're going to minimize that variance, F12, minimize it. We're going to do that by changing these cells, the weights in the portfolio, C6 through C610. And here are our constraints. Our first constraint is that our expected returns from our portfolio, here they are, must be greater than or equal to a constant that we set. And we currently set that at 0.10. So that's our first constraint. Our next set of constraints is that the sum of the weights equal 1. Here's the sum of our weights, so let's add a constraint that this is equal to 1, not 2, 1. And then we want each one of our constraints to be greater than 0, or each one of our weights. So let's just add that. That must be greater than or equal to 0. Add another constraint. This one must be greater than or equal to 0. Add the next one. This one must be greater than or equal to 0. This one, add another one. Must be greater than or equal to 0. And finally, this one, which is nothing in our case, but this one, add. This must be greater than or equal to 0. Now let me make sure this objective function is F12. All right, we got her set up. Our objective function is F12. Make sure when you run that you have the right objective function. All right, now the way this is set up right now, we are going to minimize variance given the constraint that expected returns have to equal to 0.1. That happens to be our weight. 100% of our portfolio now is in 0.10. we will be able to come up with a portfolio that has a lower standard deviation or variance by putting together combinations of assets. And let's do that. Click Solve. So now it's going to solve this. And it's going to take a little bit for things to load. Don't get excited. Just be patient here. Sometimes this takes a little bit of time. Sometimes it doesn't. And just wait. And then you're going to say keep solver solution. Okay? Keep it. Now you'll notice our weights have changed here. We no longer have 100% of our assets in stocks. We now only have 20%, 7% in T-bills, 7%, 24% in T-notes, 49% in land. We are still getting an expected return of 0.10, but look at the standard deviation. Rather than have 100% stocks, we have lowered that standard deviation from 0.17 to 0.057 by putting a portfolio together. We have land in there, we have stocks, we have T-bills and T-notes. We have all four of them in there. That portfolio happens to be the one that minimizes the variance.